we're going to look at basic probability. We're going to focus on 3 types of what they consider random number generators, okay? And probability is kind of the chance of said event happening, assuming stuff is kind of pulled at random. Okay, so there's a little diagram, nothing's really put into it. But the probability of an event, okay, so the probability of an event is the number of times an event will happen. So number of we'll say, you can almost say like true tests, or number of events happening. It's kind of vague, this term. Divided by total number of events. So, and this is kind of poorly worded. I probably should have pulled it out of a textbook. But the idea is, say that, and they usually refer to it as, you could say that the event, okay, so number of events happening, and the number of events that would not happen. And I'm actually looked up some better definitions, so let's use these 2 instead. Probably being the probability of an event happening over the total number of events possible, okay? And always your probability, so if I take the probability of this event and the probability of the event not happening, that'll always equal 1 or 100%, okay? So probability of the event plus the probability of the event not happening is equal to 100. And again, a better probability term would be total number of events, number of outcomes of event A, and that's what this guy is here, over total number of events. Actually, our definition wasn't terrible. This one's kind of pulled from the textbook. But kind of very vague theories here. And there's one other thing. There's the theoretical probability, okay? So we'll call our theoretical probability, and our practical probability, okay? And the theoretical thing is what we're going to be talking about. We're going to talk about theoretical, so we're going to run a whole bunch of tests. The practical is when you actually run an experiment. Okay, and there's a strict definition for the theoretical one, but I'll show you some examples of the theoretical one. So our very first example is talking about coins. All right, so let's say we have a normal coin. What are the options on a coin when you flip it? What are the 2 options you can get?
Heads or tails.
Yeah, and a lot of times with basic probability, it helps a lot if we build like a probability tree. So you have the option of getting heads, okay, and you have the option of getting tails, okay, which means how many total outcomes are there in one flip?
2.
2, okay. So the total number of events for our probability of the first one, so our probability, total number of events is 2, and it depends what we want, what we're trying to measure. Let's say probability of getting tails. Well, how many ways can you get tails in one flip? How many times?
1.
Just 1, right? So there's only 1 number of outcomes of event A. There's only 1 outcome of tails. So you have a 1.5 chance of getting tails and a 1.5 chance of getting tails, okay? Now, assuming that these events are independent, what that means is if I flip a coin once, the next flip isn't influenced by the following one, okay? We flip a coin again, okay? Let me do it again. All right, here's the idea. What are our options? We can get heads and tails, or we can get heads or tails, right? And again, those are 50%, but this time, when we flipped our coins, okay, we have 1, 2, 3, 4 different outcomes, okay? And this is a little advanced already. We were really just setting up probabilities before, but there's 4 different outcomes, and in this one, we could have went heads, heads, we could have went heads, tails, here we could have went tails, heads, and here we would have went tails, tails again. But again, always a 50% chance with a coin, okay? So this value is really, really important for us. Our second example, we're going to talk about dice, okay? So on a normal dice is normally made out of a cube, right? How many options do we have in that cube?
6.
That's right, we have 6 options on a cube, right? So the options are, if we were to roll once, roll one time, you have the options of the number 1, 2, 3, 4, 5, and 6. Okay, so what's the total number of outcomes here for the probability of a dice?
6.
That's right. So our total number of outcomes, the number 6 on the bottom for one roll. Now, depending what we're asking, if we're asking probability of rolling a 1, what is it in that case?
1/6.
Yeah, it'd be 1/6. What if I say probability of getting greater than 3? What do I say greater than 3?
3/6.
Ah, that's right, because how many probabilities? What are the options? We have a 4, a 5, and a 6, right? So that ends up being a 3/6, which is equal to a half. So that probability changed. So what becomes important is what question are we asking? That's a silly looking question mark, okay? Are we asking for one value? Are we asking for greater than certain value? We can say less than 6, and then you got 5 options, so you have a 5 and 6. But that's essentially the idea of how to set up a probability with a coin, okay? And finally, example 3, a deck of cards, okay? Do you know how many options there are with cards?
52.
That's right. Because there are 52 cards in a deck, I'm not going to draw them all out. Cards in a deck. This is like an English playing deck, they would call it. There's a probability is always going to be some number out of 52. Okay. So there's usually lots of options here. They break the decks up many different ways. They break it up by color. Okay. How many colors are there?
2.
2. So there's 2 colors, which means half the deck is one color and half the deck is the other. So for colors, you have 26 cards, okay? The 26 red and 26 black. Okay? And these are just some things that you might need to know with those. Color, we can go by suits, okay? Do you know how many suits there are? 4, that's right. So that means there are 13, I'll just draw them out, clubs, 13 spades, 13 hearts, and 13 diamonds, right? So those are all your options there. Sometimes they'll break it up by suits, colors, face cards. Do you know what face cards are?
The kings and the...
Yeah, okay. So per suit, there are how many face cards? You have your jack, your queen, and your king. So there's 3. And how many suits are there? 4. So you have 3 by 4, which means there are a total of 12 face cards in a deck. Okay, and as long as you know like how a deck is set up, you can kind of build from there and there. So probability of drawing a face card, you got 12 and 52. Probability of drawing clubs, 13 and 52. Probability of drawing black, 26 and 52. All of these are different types of probability, and these are the types of random number generators you're used to find probabilities.